npm install. Does it say yarn? Let me change that. It says yarn, that means npm. We had a confliction on whether to use which one, and we said we'll use npm, but some things are not changed back. Yeah, this guy likes to, he's got a lot to say. So yeah, you'll just go over probably installing your app on Heroku, or how you install any app on Heroku, which you can use the same technique. And then I'm sure he'll give you the attendance code immediately. So y'all will be happy about that.
Did you have both days or you saw it?
Both days. Yeah, it'll just be work days, which we pushed to the end. So that's not really, this class has had a lot of firsts. So it's not normal that we haven't had really a day for just working on projects, even though we've had the last 30 minutes to do that, which adds up to several hours, but we haven't had a full day dedicated to that. So it's there if you need it. Usually people want that. They want help from people who know what they're doing, but y'all seem to know exactly what you're doing.
Wait, you want me here at all?
Not next week, no. What do you mean at all? Like, would I be here on a Tuesday?
I don't know.
No, I have to be gone the entire week. I got to go to Destin, Florida.
That's never really a thing.
Well, graduation. Yeah. So, yeah, some of y'all said you were looking forward to me bringing drinks the last class. Maybe, I guess Renee did that, but I don't bring drinks to class.
Yes.
I would take y'all out to a bar, but
That's so much classier.
yeah, it's classier. But that's what graduation is for. We go out for drinks after that, when y'all are all done with your projects and everything. So, an error? Oh, yes, thanks for pointing that out. This project is set up a little bit differently to be more realistic. So there are two folders that are in the repo. But the thing is, they're just together to organize it, just so you're not downloading two repos. But we have to consider these as two separate projects. So you'll do the npm install in the client and server separately. That is just to demonstrate that normally you're going to be building or working on projects, and the client and the server may be separate. They're not tied together. And it's also just to give you practice to realize that there's a difference between what you're building in the client. That's the Create React app. That's all it is. But then the server, that's totally different. That's just an index file. Just because they're together in a GitHub repo doesn't mean they have anything to do with each other. So just trying to give you some practice on disseminating these things. Right, it's not going to work yet. Yeah. So let's see, let's work through it. Step by step. Okay. So yeah, do an npm install in both the client folder and separately, and then the server folder separately. And don't start it. Yeah, don't start it. So, what's authentication? Yep. There's not a single website that you use in everyday life that you don't have to log in with your username and password, except maybe Google. Or maybe some news site. So there are plenty. But if anything that's important, you probably use a username and password. And it probably just comes natural to you. You just, it's just second nature. But does anyone know why do sites like LinkedIn have to have a username password as opposed to NewYorkTimes.com? You wouldn't need a username and password. Yeah, you make changes to stuff. You shouldn't be allowed to make changes to other people's stuff, so they have to know who you are. So that's what the word authentication means. It means saying that you are allowed to do something. Let's see. So I'm just going to walk through this, and then I'm going to make you think about how you would build this authentication system. It'd be like a mini quiz game. So when you go to a site and you what was I using today? Wayfair. And you sign in or sign up, create an account. So usually you create an account first. Email, password. Where does Wayfair store that information? Server, database. Yes. There is no magic place that usernames or passwords are stored. It is just information, and all information gets stored in a database. So you already know how to do that. Right, so side note, there's everything, almost everything involved with this process you already know how to do. You could probably think of it yourself if you took some time and were like, how do I make a login and a sign up system? You could probably figure it out yourself. But we'll go through it. So we're using MongoDB. That uses Mongoose models. What do you think the model would be for signing up with an email and a password, or saving that information? What would the model be? Because you have, or the collection, because you got to have a collection, then you have to have a model. But if they link together, same thing. What would that be for a username and a password? Users? Yeah. Yeah. Login, users. Yeah, I would agree with both of those. But again, there's no right answer. But the most common term for it would probably be users. Because what other kind of information might you want to save on a user's model besides email and password? Name. Date signed up. Yep, all that stuff. Exactly. So if we look in this project in the server folder, there's a user model. And it just, our simple one has username, password. So next step, nothing's weird. Nothing is anything we haven't done before. Let's see. Did I start this? Let me start the server. So I'm going to introduce, if we look at the index, which is just the normal way we're starting up our server, I'm I'm going to introduce one more concept that's pretty important. It doesn't have anything to do with authentic.
I'm sorry, are you recording?
Yeah. I am, right?
Sorry.
Yes. Cool. Yeah. So if you look at the index for the server, nothing should be out of the ordinary. You have express, use, body parser, listen, all the same stuff. Nothing's new in here, except one thing maybe. What is that code I highlighted? Anybody familiar with that? Okay. Well, when you use Mongoose Connect, what's supposed to be right here? Yep, the connection string, the thing that links up to your MLab, which is this thing that MLab gives you. So we've done that several times. So, but this looks different. So somehow your connection string is supposed to be right there. So how is it getting there with that weird what process.env.mongodb URI? Any thoughts, guesses? So has anyone seen this file before? .env? Okay. So you might have run into it out there in the world while you've been doing your own research and stuff, but okay, so if I put it back to the original way that we did it, wait, with quotes. Oh, what'd you say, Will? Yep, so, right. So the question is, if I do it the old way, and then I complete my project, and I'm like, okay, I need to push it up so that everyone else can connect and have Mongoose work, what's wrong with doing that after I do a git push? Yeah. As soon as you push this up, now the entire world can see your username and password. So I don't care right now because it's just the test stuff, but if this is your real database, you don't want people to have your username and password to your database that's for your project that has all your data in it. That's very bad, very, very bad. So we have to come up with a way in which your information that's sensitive can be stored somewhere, but when you git push it, you don't include that sensitive information. Right? So there's the git ignore with the .env, which tells it ignore it, don't push it up, because I have all my very sensitive information in there, and I don't want other people to see it. I created it. Right, so good question, because then I'll say, well, if I don't push this up, then how is anyone else supposed to have this so that the project will work? How? I'm asking you. Yeah, how does anyone else get that? They need that, but it's not in the Git repo. Yeah. Yeah, exactly. It's not a trick question. Anyone else who works on this, you say, just make your own env file and put, either you can get, if you're just testing, you can just give them that, or you tell them you have to put your own information in there, your username and your password. And that's just the setup process. Yeah, exactly. Regular text, some key equals some value. Okay. So then if I go back over to index, do you see where this word comes from? Where did that, process.env is just the standard, it's always this. It refers to this file, but then what does that refer to? The MongoDB URI. Yeah.
It just goes, it knows to search for that.
Yep. Exactly. It just knows. Right. It's smart. This is a smart thing. So it just knows, look for this word in this file, and then get that value. That's after the equal sign. That's automatic behavior. It just works.
So the signature backup is forget about it?
It's another.
Nope. But good question. These values are all random and arbitrary. There is no special thing that has to be in here.
Yeah, but if you put like process secret.
Yeah, exactly. If you do process.env.secret, which we'll see in a second, it being used. But yeah, this is all arbitrary information. You can put whatever you want in here. Yeah, it's just up to you. It's up to you to decide what goes in there. Okay, so that is that. That's why that this is here. And then that's why you don't have that file. You have to make it yourself so you can put your stuff in there, your database in there. And it's just this. It's just new file .env. That's it. Let's see. If you want to throw that in there, just put that in the chat. I don't care if you use my database since it's for practice. But don't use that password because that's the one I use for my bank account. Just kidding. All right. Any questions on that? That's it. That's all there is to it. I just wanted to throw that in there because that's very realistic. You don't ever check in or push up your secret special information that anyone could just see. It's terrible security to have. What else? Okay, so everything that's in here is already coded pretty much. So we're not going to really have to code anything besides that env thing. It's already going. Let's see. So there's user routes. There's the standard routes, user routes, controller, all that stuff, same stuff. User controller, create list. So all that stuff still applies. That's all in there. But so if we create a user, we sign in, we go to the create function, our standard thing, and we're about to make a user. The next thing I'm going to ask is, when you store a username and password in the database, say you signed up for LinkedIn, do you think LinkedIn's employees are allowed to look at the database where your password is stored? No? Does anyone think they are? Maybe? Engineers? DBAs? What's a DBA?
Doing business apps?
The what?
No, it's not doing business apps?
Oh, no, that's a different meaning.
Well,
But in terms of software, what's a DBA? Yeah, database administrator. Good try. So in any company where there's a database, there is some person who has complete control over the database and can do whatever they want to it, look at any information. So what do you think, how do you think that's a security threat to when you're saving passwords in a database? How is that bad?
well, somebody could bribe them
Bribe them to do what?
to give them my password.
Yeah, exactly. that person could do anything or could do something malicious if they wanted. Probably several people could. They could look at your password, and even though it's for your LinkedIn account, maybe you use that password for your bank account too, or your Facebook account, something like that.
But isn't there double security? Like if somebody logged into my account, I would get like a.
Yeah, if you set that up, you're right. So, but does that make it okay that someone can see anyone's password? No. Doesn't make it better. I mean, it doesn't make it right. Yes, that what do you call it? Two-step. Yeah. That helps against this a lot. But what if then you use that password for your email? Then they could hack into your email and then answer the secondary security and say, yes, accept this. So the point is, you cannot save a password in the database plain text, like as it is. That's a huge security threat, and it's against a lot of laws and regulations for business websites. 2001. Yeah, that's what it looks like. If you start the client up, that's what it should look like. Just a simple sign up. Sign in's not made because that's your job. That's the assignment of this project. Is you have to do it separately. Yeah. So the server, you start with node, just node space index, the normal way. And then the client app is a create React thing. So you could do the npm start on it. Does that make sense? It's two separate things that need to be run on their own, right?
It usually fixes the login or the server start.
Yes. The env will fix the server, or it will make the server run properly. So you can just use the credentials I put in the chat if you just want to get it working real quickly. And then put your own in there later on.
What is the file need to be? What does the ENV need to be?
The root level.
So right next to it.
Yeah. So the env has to be at the root level of the server folder.
Say for the client server with NPM start.
Yeah. For the client folder, you can do npm start. We don't need to do that though for the client because we're not looking at that currently. We're looking at the server. So yeah, I'll wait a couple of minutes. Get the server working. The client doesn't matter because we're focusing on what happens in the server first. Yeah, all you need to do is get that env file in there and then node index. Everything else is coded. We're not coding anything in this project because it's too complicated. We just need to understand the code that exists. Yeah, just copy this text. Did anyone get it working? Got it working. Okay. Okay. All right. Yeah, if you didn't get it working, we'll look at it after this. But we don't have to code anything, so you're not missing out on me telling you how to code anything. It's already all in there. If I do a postman, if you notice the routes that's set up, user, there's a post, and what does a post do to a user? What's the intention of posting? Creates a new one, yeah. So if I just post to that, so this is the URL because I just ran it on 3001. That's just the port I picked. I chose the path to be /API/users. Why did I say /API? What does that mean? What's an API? You've used an API before. What's API stand for? Application Protocol Interface, yeah. So you've used things that people have termed or referred to as APIs. Yeah, that's what you fetch. Well, when you build your own, it's usually standard fare or standard procedure to put API in your path. It's not a rule, it doesn't have to be this way, but it's just best practice. So anytime you use a certain technology that that is pre-built, they usually have API in the path, but we're building this ourselves, so I'm choosing to follow that pattern. So we got to remember the path we set up can be anything. It could be any random word you pick, but the industry says make it start with API and then / whatever it is else that you're trying to make. So that's something to just be aware of because you'll see that out there when you work on a company's API because they probably followed the standard naming convention. So a user just has a password and a username. And I'm going to post that. Okay. So I posted test password. I'm going to go back to my database and I'm going to check out what's in there now. Okay, here's one I just did, username, password. What is that? Why did password change to a big jumble of random characters? Hash, encrypt. Yeah, those are good words. So I told you you cannot store a password in the database as clear text, as it naturally was. So if you go to the user's controller and you look at the create method, none of this code should look out of the ordinary. It may look slightly confusing because there's a little bit more of it, but there's nothing code-wise. This is all stuff we've already done. The user model. Why do you think when I'm trying to create a new user, I first try to find one by the username? What's the point of that?
See if it already exists.
Yep. Well, I think you should be familiar with that concept. You can't pick a username that somebody else already picked. That's just a standard thing to do. So we know how to do that. We use our model to try and find the username that the person picked. And if it exists, you just say, sorry, username is already being used. You can't do that. Otherwise, we're going to go down to the save user function. And as Sean said, we're going to do this thing called hashing. So what is hashing? This can get complicated, so we're not going to go too deep into it, but we just have to understand it very superficially. What's hashing? You said hashing, Sean. Do you know what it is? Jumbling it up? Yeah. What's the difference between hashing and encrypting? Yeah, hashing and encryption. What's the difference?
Hashing is like a digital signature of whatever you hash.
Whatever you hash. Yeah.
Yeah, so encryption tries to hide like whatever data is being encrypted.
Yeah.
Hash, it's more used to, I don't know.
Jumble it up.
Well, it jumbles it up, but it will.
There's one specific characteristic that I'm looking for. That's the main thing about it. What? Yes, that's it. So with the concept of hashing, so this is just like in the movies, encrypting stuff, right? The spy goes in, you encrypt information. They go through the whole movie trying to find the thing to decrypt the information. That's the whole basis of the movie. This is the same exact thing. But there's this other term called hashing. All you have to know about it is hashing is where you jumble something up, but you cannot reverse it. You cannot change it back to what it was. It's impossible. Where if you encrypt something, you can reverse it. You have the special key, the spy finds the key, and they can decrypt it and know what that information was. So that's what you have to know. Hashing, you cannot reverse. Encryption, you can inverse or reverse. Right, the password's forever like this. Exactly. You can never reverse it. The DBA can't go in there, look at that, and then figure out what it used to be. It's impossible. That the original password is lost forever into this jumble of words. Right. Mm-hmm.
It'll send, if they match, if the user puts in the right password, it'll send that same jumbled match.
Yeah.
Then it's the same password.
Mm-hmm. Exactly. So, well, first are there any questions on that?
So the same exact thing, they set that same exact
Yeah.
password.
Mm-hmm. Right. But is there any questions on hashing versus encryption? We don't need to go, we're not going super in depth, just that same one concept. You can reverse hashing. But then yes, the next question will be, if you can't reverse it back to what it was, then how the heck do you know if somebody entered the right password in? But as y'all said, that's exactly right. When I log in when I log in and put in my password, it will hash it again, and hashing always stays the same. Whatever word you put, like if my password was this, the hash will always be the same. Therefore, you can compare the hash to what's saved in the database and match it up and make sure it's the same thing. Does that make sense? Any questions on that? Yeah, exactly.
There's no way. Yeah, when I worked at Apple, I did tech support for them, we would always call in and ask, can you tell me your password? And you literally do not know it, and it's impossible to find out.
Right.
It's for security, so nobody can put it in the database and steal them or whatever.
Yep, exactly. So now you know the secret. Why they asked you to reset it, because it's impossible to know what your password was to tell you or retrieve it. So, cool.
How secure is the hash? Did you figure out how?
No, right. So that's a good question because many people will bring that up. If you know how to hash something, how can you possibly not know how to undo it? You just can't. Like that's way beyond. That's like complex mathematical equation type stuff.
Well, somebody was created.
Yeah, some very smart people. Yeah, right. We're about to look at that. So we'll point that out. What this hash is. It's in the service folder, and we're using a tool called bcrypt. So the process of hashing is not a secret. It is a standard out in the open formula that a very smart person at a university came up with, a genius mathematician, figured out how you could make this jumble, but then nobody can ever reverse it, even though you know exactly how the jumble was made in the first place. Right? To us, that boggles my mind. Like, how is that possible? But it is. And so we're just going to take it for granted, and that this tool, this package called bcrypt, has implemented that algorithm so that we don't have to do it ourselves. Obviously, we don't want to write our own complicated mathematical formula when someone else has done it perfectly. So we're just using this tool, and we're just going to take it for granted. And all it is the tool has a hash function on it, and then you just call hash, and then it makes this jumble for you, and that's what you save in the database. Okay. Can get a little bit more complicated than that, but for our purposes and your projects, that's all you would need. Yep, and all this code is already in here. So you want to look at the user controller and just follow the code path down to the save user, which uses hash. And then after the hash is done, that's when it saves the user model. So you don't have to implement all this, but you should study it a little bit and make sure you understand what's going on. Because this will work as is without adding anything to it. I did not want y'all to have to code this yourself. But if you go work for anyone that uses a login system, and especially if it's Node, any programming language is going to look similar to this. But especially if you use Node, this is exactly what they're going to do. So now you know the secret, why you have to always change your password if you forget it.
So this is top level security.
Yes, almost. There's like maybe one or two more things that could be done to make it even more jumbled. But yes, this is realistic top level security. Because it seems so simple, and it just seems crazy that someone built in a Node package like the most secure encryption that you can possibly use, but that they did. It's just that simple.
I don't think that each time hash is called, it creates its own instance for that server.
That may be correct.
Every server
Yeah.
has its own.
Every server has it's based on something that is specific to the server. Yeah. Yes. So we're not going to go that far into it, but you're right. There's got to be a little bit more to it. So we just hash it, save it in the database, and it is just there, now stored as a piece of information as a user. That's it. Any other questions on that? So now you have your users, like all your users that signed up for your app are now in the database. You can't see what their passwords are, but you can see what their usernames and whatever else you wanted to add to it. You could add anything to it. Let's see. I have not been paying attention to the checklist because I already know all this off the top of my head. Oh, I like to point this out, even though you may not even have noticed it or thought about it. So we're signing up. Some people will say, why isn't the model called sign up? Gotten that question quite a bit. And that is an important point, which it's trying to demonstrate that just because the interface has certain wording, like sign up, that doesn't mean your model has to be called that or your collection. So users want to see the word sign up. They don't want to see the word users or like make a new user. That just doesn't make sense. You're signing up for something. So this is like a side note. Just because your model's named users doesn't mean the interface should say that. So you can separate that. That's a very important distinction because that causes a lot of confusion in software design where they're like, what are we going to call the thing in the web page versus the database collection? So keep that in mind. Side note. Hash. So we can sign up. I'm using Postman because I didn't want you to start the client yet. It doesn't matter. We're using Postman to see what came back. So the next question is, when you sign in to a website, do you have to keep signing in every time you go to a different page? No. So how's that work? How do they know that you already signed in so that you never have to sign in again? Right, but then you go to different pages. Maybe you go to your wall page, your friends page, your pictures page. How do they know that you're still signed in when you go to different pages? Cookies? That's a good point. Token. Does everyone know what cookies is? I don't know if they taught you that in intro. I'm not sure if that's a thing. Did they? Did y'all talk about cookies? No? Okay. Cookies is an old way to do it, but it's still important. You should probably look that up. I'm sure you've heard about it, even having nothing to do with the school, like cookies. You have to accept whether a website can use cookies or not. Right? So that is one way. They can use cookies to know if you're signed in. But these days they do it differently. Most systems use a thing called a token. So a token, does anyone know what a token is? Sean? Yeah, when you put in your username, password. So the analogy for this is just when you go to a concert, you pay your money, you stand in line, pay your money, give them your ID, do all that stuff. You want to leave, and then when you come back, you don't want to go through that whole process again. What do they give you so they know that you already did all that? Stamp, wristband, yeah, all that, whatever. The same thing apply. We do the same thing with software. We give you a wristband, but it's called a token. So you don't ever have to sign in again. You just keep giving them your token, and that proves that you're logged in. And that's, let's see. I go back to the user controller. Save password. This thing's called token for user, which is just this. If you look in the token file, it's very simple. We see the word encode. So all we're going to do is encode some information, and it results in this jumble of words. So what is, because it's encoded, what does that mean that is possible? The what? Yeah, it's reversible. You can decode it. So if you just got a token with a jumble of words, then how would that prove anything? You could just make up your own jumble of words, and the server would be like, okay, you gave me some jumble of words, you're logged in, great. Well, that doesn't help anything. It has to have meaning. So the server can decode it and know that there's something meaningful in that token to prove that you already logged in. Here's what's in it for our project: user ID and a timestamp. Encoding this information right here made all this jumble of words. So there's no way any normal person could know what that is. That's what encryption does. And it's just this simple, one line of code. You can look at that yourself, study it. It's a tool called JWT Simple, JavaScript Web Token Made Simple. And it's just a standard tool used in the industry to make tokens by encoding something. That's what this secret is for. When you encode and decode stuff, there's got to be a secret key. Otherwise, you can't decode it. So that's why that was there in the ENV file. Yeah, that's your password. That's the key that the spy spends the whole movie trying to find. But for us, it's just right there in our ENV file. What? Mission Impossible?
So when you created your server, you created the secret yourself.
Yeah,
You didn't,
exactly. The secret is just whatever. Like, it's a word that no one could ever guess. So it could be whatever. Do you think anyone could ever guess that?
and that's not something that you'll never have to come up with.
Correct. Yeah, you'll never have to come up with it. You just make whatever it is you want. Mm-hmm.
So that's not your input.
Correct. It is the secret key to encode and decode your token. Yeah. Yep.
So where is it stored on the user?
Oh, good question. We'll look at that next. We will look at that next. Well, the thing is, the user's computer, the client, does not need to decrypt or encrypt. It just needs to have it and then send it back to the server every time to prove that it was logged in. So the client, your web page, never needs to encrypt or decrypt anything. It just gets this token and just holds it. Like your wristband at the concert, you don't know what it means. Maybe there's some special like message on it. You just have it and you say, here it is. And they say, okay, come back in. The client never knows what this is. They just have it. Yeah, it's randomized. Oh, well, right, exactly. Good question. Why is it randomized or special to each person? What makes it? Yeah, exactly. The timestamp. Well, actually, it's two things. Yeah, username and timestamp, right? So the timestamp's always different, but then even if two users did it at the exact same microsecond, everyone's user ID is different. So this is generating. Yes, yes. Mm-hmm. The secret's always the same, but the token generated will always be completely unique because nobody's user ID is the same. That's the key. nobody has the same user ID unless your system's broken. And the timestamp will almost always be different. Yeah, so it's always going to be different. Why would you care, besides that, why would you care about a timestamp? What value is there to know when somebody first logged into your website? Why is that valuable? You've seen it before. Could be.
Kick them off after a while.
What?
So you kick them off after a while, or,
Yeah.
or something?
Yeah, exactly. Kicking you off. So you've seen it when you use bank software. They're like, your session's about to expire. If you don't move or do something else, yeah, they use a timestamp because they want to know if they should log you out, which is a security thing. Banks have really strict rules, and that has to be implemented. Stupid Wells Fargo.
So what if you're on, something like Google and you're constantly logged in?
Mhm.
So it has to put something on the computer,
Right.
right? Like on
Google would use cookies.
Okay.
Google would-
These are the way to do it. To have it on the computer constantly. But like
Yeah.
the timestamp of this, would put it in memory, it would be clear every time.
Correct. Almost. Yeah.
Okay.
We'll look at that in a second. But you're on the right track. Yeah. You're thinking correctly. Right. So all that stuff that you just said, that's up to you. So when you design your system, you decide, do I want my user, once they're logged in, like I haven't logged out of Facebook in 5 years because they don't ever log you out. And I've never used Facebook, but if I go on it, I'm still logged in from 5 years ago. I'm like, what? That's because that's how they designed it. That's not true, I mean, because I've gotten a new computer, but they'll never log you out. Your bank software will log you out. And that's up to you to design how you want that to be. Facebook doesn't need security, so they're just like, yeah, just make the timestamp infinity and never log you out. So you think about that. For most cases, you'd probably not want the person to be logged out very often because that's inconvenient. And y'all's apps probably wouldn't need to be very secure, so you wouldn't care about that. But just depends. So that's
I have a question.
good to think about.
What could actually happen if I was logged in?
To what?
Like, when I'm logged in, what makes it that I'm like so much more vulnerable to a security system?
I'm not sure. You aren't vulnerable.
So what's
Theoretically, you should not be vulnerable. Once you log in, there's no way, except if you leave your computer and someone else sneaks over to your computer and starts doing stuff on the website you already logged into. There's no security flaws with this. Are you talking about like something you heard in the news or something?
I was just wondering why is it that they log us out so often?
Oh, for exactly what I just said. If you leave your computer and then someone else sneaks over and is like, ooh, that's how much money.
Like,
The what?
decrypt your password as you're logged in.
No, they can't do that. No, it's just you may be like distracted by something, like looking on the TV,
Okay.
go over there and someone sneaks in. Of course, that's not really something that's going to happen, but it could, and banks can't take that chance.
I do actually have a little insight as someone from IT.
Awesome.
Someone theoretically could intercept that token over the network traffic as it's sent back from the server. If it's a permanent token that they don't check for timestamps or anything, then they can reuse it. If it's constantly reissuing that token or logging you out, then even if they were able to intercept it, it won't be good for very long.
Right. Yeah, that's similar to that premise. If someone,
So you lie to the teachers.
so if you, well, it's not exactly totally accurate because it's almost impossible for someone to intercept your token unless they're using, yeah, and that's a good thing to look at. What is HTTPS? Yeah, secure. So I'm not exactly sure maybe what you were referring to,
Yeah, I mean, it's
but if
The likelihood is very low,
Yeah.
but that's just an extra layer of security.
yeah, you're right. It's pretty much never going to happen. But as long as this S is here, no one can intercept your internet traffic. No one can, between your computer and LinkedIn's computer, no one can intercept what y'all send back and forth. It's impossible. That's why the industry works completely fine where you're sending your credit card numbers to Amazon. Until Amazon gets hacked and 500 million people's information is stolen. Wait, who did that just happen to? Google Plus and then someone else. Oh, Marriott. They had their database hacked. Hopefully they were using hashed passwords, but they still get personal information. But that's when it's in their database. Somehow they break into that. But through the internet, this S right here prevents anyone from intercepting the requests, the messages that we've been talking about. And we could go into that, but I don't usually, it's too complicated. But good point, good thinking, good questions. This is all, this should be interesting stuff. Where did we leave off? Token, we got the token. Okay, so last thing on the server is how does the server care or how does the server aware of the token to say like, okay, you have a token, you're signed in, or you don't have a token, you're not good, you're unauthorized, go away. So if I go to, let's see, I'll go to this route, which is just a get, so I can just put it in the browser. This route says invalid credentials. If I'm trying to go to this route, what do you think makes that happen? In this code right here, who can guess? What's making this thing say, and I didn't send a token. What do you think, what code makes it say invalid credentials? Good. Good guess, or good knowing. So the routes is just it's just a use. And so this is the code that actually checks for whether you have the token or not. It's checking a header. The header is where the token should be, and then it decodes the header, and then it uses the ID to find the user. If there's no user, it sends invalid credentials. You can study that as much as you want. We don't need to get too much into it, but that's the bouncer. The bouncer that's checking your bracelet is the authentication controller. And that's it. I think we went over this. I think we talked about the next. Didn't we mention that? I think someone asked about it, and I said, well, you're going to see a reason. We went over it, but now you're seeing a realistic reason why next exists. Because if they're authenticated, then we call next. Otherwise, we just send back invalid credentials, which stops the whole process. So, which one? Next? Yeah. That's always part of the route functions. It's request, response, and next. Yeah. So that is, yeah, you can study that.
I'm sorry, what is the next? Route?
Yeah, calling next is what makes the server continue on to the next route. Yeah, if you call it, that's the thing that makes that happen. So authentication routes, we talked about order matters. Authentication routes is here. Everything else after it, this is all secure. Because if you don't have the token, the bouncer is not going to call next, and none of this is accessible. This is all secured. So the point is, whatever you want to be secured has to be down here after authentication routes. That's all that's the only technique that's securing this is the order. So we're like, user routes, that's not protected. Why are user routes not protected? Why wouldn't you require a token in order to give your money and your ID?
Because you need to log in, log out, register.
Yeah. Yeah, you have to be able to sign up and sign in freely without being checked for a token. So that there shouldn't be security on this. While you're waiting in line at the concert, while you're paying, you don't need security because you haven't gotten the token yet. Everything else after it is where the security is needed. So you could put anything you want up here that doesn't need security. And that's all it is. It's whatever's up here, not secure. And then whatever's right here, secure. That's it. That's all that determines that. So you would think in your apps, what do I care that anyone can see or that only logged in users can see? That's a choice you have to come up with. And then whatever needs to be secure down here, whatever's open is up here. That's it. This one? That's another syntax for catch-all. Yeah, like anything else. Yep. Yeah, catch-all.
So it'll shoot it back to the main page.
Right, exactly. Anything else just sends you back to, or sends back this file. And that's it. These routes, these are just random routes that I just made. They're not important. It's just for demonstration purposes. So you can see invalid credentials. But if I now use Postman to take this token that was made and actually send it now I'm using Postman to actually provide my token, be like, here, bouncer, there's my bracelet. Now it actually sends the stuff back. It actually hit that route. I know we didn't talk about headers too much, but all headers are is just some word equals some value. Some word equals some value. You can look that up yourself. And you can make any header you want. I can make whatever header and whatever value. It's just random key value information, just like an object. And that's part of an HTTP message. Okay, so that's it for the server. Yeah, we won't take a break. We're almost done. Then we'll stop. Any other questions on the server code? Get it? Postman?
Yeah.
Okay. First, you have to do the post to API Well, let me do a new one. First, you do a post to the API users. That allows you to get the token. The body, you have to look at what body is expected. And in our case, it's simply username, password. So the client is constructing its message in an attempt to sign up to the Path API users with a post and sending in the information of a user. The server takes that information and says, all right, you gave me a username, you gave me a password, that's all I need, you're good to go. Here's your token. You gave them your ID, your money, and the bouncer gave you a bracelet. So you leave the concert. Now I want to get back in the concert to the stage called Can I Get This? You give the bouncer your token in a header called authorization. And in this case, it's just a get. Yeah. So you have to get the token first. Otherwise, you don't have your bracelet to go anywhere else. Okay. So does that answer your question or make it clearer?
Yeah.
Help?
I just didn't know what to do.
Oh, yeah. Put it in a header called authorization. Okay. So that's the workflow, that's the process, but we did that through Postman, which obviously is not realistic. Nobody's going to use Postman to log into anything. So that's why we use a web client, which is in the client folder. There's a lot of code in here, so it's going to be up to you to explore this and figure out what's going on. If we just look in app, there's a function called handle signup. It's doing a fetch. So it's doing exactly what I just demoed through Postman. We don't need to go through that because you can look at this on your own. There's nothing new. Well, there's one thing new, which is the only thing we're going to go over. So once you get your bracelet from the bouncer, how does your code in your web page hold on to the bracelet, which is the token? How does the web page hold on to this information for 20 minutes? How would you code that? Would you put it in a variable? Was it? You could. State is just like a variable, so you could just keep it in state, the state of your component, but I wouldn't recommend that. You're on the right track though. What happens when you put it in state, but then you use React Router to make another component show up? That other state disappears, and so your token disappears. What's a more universal way to save information, a more global way, more permanent way? What kind of variable maybe? How can you save stuff in your web page to where it will just be there available all the time from any code? This is from intro. What did I just do? What kind of variable is this? What? Yeah, global. Yeah, you can make a global variable. The global variable is just going to be sitting there for any code in your entire app to use whenever it wants. That's one approach. But what's the downside of that? Maybe if you care about this. What happens to global variables when you refresh the page? Yeah, it's gone. It no longer exists. Right? So if you want your user to be logged in longer than refreshing the page, you can't do that. What's another way that you can store information that stays there even after you refresh the page? Not an array. Well, you could use an array, but where would you put the array so that it stays there even after you refresh the page? Sure, array, object, but those things can't just be floating in thin air. They have to be put somewhere.
Local storage.
Yeah, local storage. So maybe you've run into this, maybe not. It's kind of an important thing to be aware of. Your browser has a quasi database built into it to where you can save stuff permanently, even if the web browser closes down and restarts. Do you think that would be useful? I mean, you think you could use that tool in some kind of useful, interesting way to where you can just save random pieces of information and they will just stay there forever, even if you close the browser? Hopefully you might think that's valuable. But that is what we're going to use to save a token. It's some people say this isn't a good idea, but we're not going to worry about that right now. This is the most common approach. So when you build a system or work on a system out there, this is the most common approach. Saving a token in local storage. We don't need to go through this really in depth. You can look this up yourself. It's very simple. If you want to store something, you call set item, you use a key, and then the value you want to save. So if you're curious about that, research that a little more. I'm sure your apps in some way could benefit by saving stuff permanently. And that's it. That's how we save the token, the bracelet we got from signing in. Great. And the last thing we have to handle oops, my server's broken. Where is the, let's see, which component is requesting something? Secret. Okay, right here. Okay, so you're doing a fetch call to some secret route. What do you have to do to include the token in your fetch call? Add it. Not props. Well, the token is here. Because that's how you get it out of local storage, your database. Oops. How do you include this token right here? We stored it in local storage. This is how you retrieve it out of there and put it in a variable. How do you include it in your fetch call right here? Based on the fact that I said it has to be a header. I guess nobody has been coding fetch calls at all? This is just like how we do posts, right? You have to have a header with JSON. That's how you add headers to a fetch call. Standard instruction manual. Because that's all that we're doing. We're adding this token to the header of a fetch call, part of the message, part of the HTTP message. And that's all we need to send for security purposes. Okay. So we're maintaining this information in local storage. That's your bracelet sitting on your wrist with a little lock so it can never slip off. This fetch call is you trying to get back in the club and the bouncer saying, whoa. And then the header is you saying, here's my bracelet, let me back in. And then the club is the server and the API secret route. Okay, any questions? I know it's a lot, but you just need to go through this, review it. Let's see. There is an assignment for this, but it's not going to be. It's not going to be graded homework. Yeah. So for this project, your job is to create the sign in. So there's sign up, which is the same thing as sign in, except it's when you're making the user. And then sign in is just, you already signed up. Now you just need to show your bracelet again. But that's for your own benefit to work on if you want to incorporate it into your project for the final project or any project from here on out. Anything else about this? I think that's it. I think that's all there is to it. Yes. Any other questions or concerns? Mm-hmm. Well, you use the database. So in here, if you relate it back to Postman, what's going to be in here is this token. Your client, this big jumble of words, the web page has no way to extract that information out of it. Only the server can do that. So you will not try to get anything, any information out of this on the web page. Only the server can do that. Yeah, then they can get into the database and do whatever they want, which would be, on the server. But yep, that would be where anything having to do with the database in which it required signing in would just be putting anything like that down here, because down there is where you're secured. So all your database stuff would go here. And then you might need to know some information about your user. Well, the request is going to have the user on it. Once it's secured, the request.user is going to have all the user information on it. So you can get their ID, their username, their email, whatever it is that you put on a user in your system. That's just magically going to be there. So yeah, so you use that to retrieve stuff from the database that's applicable only to that user ID. Like if you're looking for their blog posts, you'd have to do it where user ID equals that user ID. And that's where the security is. They know what the ID is, so you only get your own blog posts, not other people's blogs. You can only update your blog posts, not other people's blogs. Anything else? All right. I guess that will do it for today. Here is the attendance code. Stop recording.